In this example, we are given the following polar equation, and we are asked to, 1, convert it to a rectangular equation, and then 2, to graph it. So first things first, I'm just going to throw up the conversion formulae for converting from polar to rectangular and vice versa, because I just remember them all together. I use whatever I need as it comes. So first of all, x is equal to r cosine of theta, y is equal to r sine of theta, r is equal to the square root of x squared plus y squared, and theta is equal to tangent inverse of y over x. Okay, so now I could right away substitute things in here and then try to simplify, but I think it's a little bit easier if first things first, I try to, instead of getting, like, I'd have to have the cosine down here, I'd have to say this is x over r. I think it's easier if I can actually get an r cosine and then just substitute in an x. But it is up to you. With that said, I'm going to multiply both sides by 1 minus cosine. And over here, I'm going to multiply by 1 minus cosine. When I do that, the denominator here crosses out. And I have, if I distribute this out, r minus r cosine of theta is equal to 1. Now I will make substitutions. The r is just not going to be that pretty. That's okay. It is equal to the square root of x squared plus y squared. Meanwhile, the r cosine is equal to x, so minus x equals 1. Now, technically speaking, this is in rectangular form, but I'm going to manipulate it until it looks like something more familiar, i.e. either a circle, an ellipse, a hyperbola, a parabola, or, I don't know, something else I wasn't expecting. So I will first of all add the x to both sides. How do I know to do this? Well, I see that there's the square root of blah, 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 blah in there. Doesn't matter what it is, there's a square root. And I don't know any formulas off the top of my head that have a square root in them intrinsically, other than, just graphing a square root of something. So I want to get rid of this, which means if I isolate it and then square both sides, I can achieve that. So that's why I'm adding the x to both sides, which then leaves the square root alone. I have the square root of x squared plus y squared is equal to 1 plus x. If I now square both sides of this, I have x squared plus y squared is equal to, and I'm going to FOIL this out. So 1 times 1 is 1. 1 times x is x. 1 times x is x again, and then x times x is x squared. Notice that the x squared cancels off. I can subtract it from both sides. And I have a 2x. Let me actually solve for the x. It's not entirely obvious I should do that, but let me emphasize that if I try to solve for the y, because it's a y squared, I'm going to wind up square rooting both sides. So instead, since the x, there's no longer an x squared, there's just a simple x. I'm going to try to solve for that instead. So that's going to involve subtracting a 1 from both sides. I'll have y squared minus 1. And there's 2 x's, so this is, well, 2x. And then I can divide both sides by 2, and I'll write that over here. So x is equal to y squared minus 1 over 2. Or in other words, 1/2 y squared minus 1/2. And perhaps this looks familiar to you. This is a parabola. Now, is it rightward facing or leftward facing? Well, because it's x equals a positive number times the y squared, I know that this is a rightward facing parabola. And so if I now graph this, let's see, I have the minus 1/2, so let me take these by ones, but very obnoxiously big ones. So minus 1, minus 2, 1, 2. So this is, and I'll graph it in blue, so this is centered at negative 1/2, and then it's a positive y squared, opening out this way. And I know that all parabolas have this general shape. I will take a little bit more care to see exactly what the shape is. If y is equal to 1, so let's say this is 1 right here, and this is minus 1. Y is equal to 1 or minus 1, because when you square it, it's positive. Then I have 1/2 minus 1/2, which means x equals 0. So it's intersecting right there. And then I can just go ahead and draw that in the nice, smooth parabola shape. And there we go. We have taken the given polar equation, converted it into a rectangular equation, manipulated it until it looks like something we are familiar with and can graph, and then graphed it. And that is this example.